Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be progressing with our second method of differentiation, which is known as the first principle method. So please, before you watch this lesson, like this video, hit the subscribe button, and lastly, don't forget to turn on notification and share to more friends and more learners. And stick with me till the end, and let's enjoy the best out of the lesson. So how does the first principle method of differentiation work? Let's say we have an example like y equals to x. So in this case, we know that when we use the general method, so if we use the general method for y equals to x, we are going to have something like, remember that the power in this case is 1 because anything raised to power 1 is what? Is that thing. So we are going to have y equals to, so the power will come to the front, which is 1 multiplied by x raised to power 1 minus 1. So in this case, our general method will give us y equals to, so 1 multiplied by x will give us what? X. So 1 minus 1 will give us 0. So anything raised to power 0 is 1. So it will be the y over the x will be equal to 1 because anything raised to power 0 is 1. So let's try to use the first principle method and see if we get the same answer. So in using the first principle method, the first step is to add the y to y and add the x to x. So this is telling us that we should add change in y to y and add change in x to x. So in doing this, we have y plus change in y to be equal to x plus change in x. So that is the first step. You add change in y to y and also add change in x to x. So that is the first step. We have completed the first step. So the second step is to carry y to the other side or the opposite side. So we have the y to be equal to x plus change in x minus y, because there is positive y here. So if you carry y to the opposite sign of the equal sign, so you are going to get what? Negative. So that is how we have minus y in this case. So the goal is just to have the y in this left hand side. That is the goal. So the goal is to have change in y in this what? In this left hand side. So the next step is to know that y equals to x, because from the question we are given that y equals to x. So we know that but y equals to x. So we can easily substitute this y for x. So anywhere we see y, we'll put x. So we have change in y to be equal to x plus change in x minus, so instead of writing y, we know that y equals to what? X. So we have minus x. So we have completed the third step. But we can see positive x and negative x. So this is positive x. So this can cancel this. So we have change in y to be equal to what? Change in x. So the last step is to divide everything by what? By change in x. So we can divide this by change in x and also divide this by what? Change in x. So our change in y divided by change in x. So you can see this is our dy over dx to be given as what? So when this divide this, we are going to get 1. So this is our final answer to question of this type. You can see when we solve this using the general method, we get the same answer as when we solve it using the first principle method. So this is how the first principle method works. The goal is to have change in y in the left hand side. So finally, you are going to have change in y divided by change in x, which is also known as what? The y over dx, to be given as what? Your final answer. So this is how the first principle method works. So let's look at another example, still on the first principle method of differentiation. And moving to the second example, on the first principle method, we have the question as written on the board as y equals to x squared. So in this case, when we use the general method, so let's say we have y equals to x squared and we use the general method, we said the simple idea is to bring the power to the front. So we have y equals to, so bringing the power to the front, we have 2 multiplied by x raised to power the power subtracted by 1. So y will be equal to 2x. So 2 multiplied by x will give us 2x, and 2 minus 1 will give us 1. So y will be equal to 2x. So this is our final answer when we use the general method. So let's use the first principle method and see how this works. So remember I said the first step in using the first principle method is to add what? Change in y to y and add change in x to x. So in this case, by doing that, we have y plus change in y. So we had change in y to y and change in x to x to be equal to, so we add change in x to this x. So in adding change in x to this x, we are going to have something like x plus change in x close bracket square, because this is having square. You can't say that when you want to add change in x to this, you can't say that we have x square plus change in x. This is very wrong. So this is wrong. So the best way is to add x to change in x and now put the power. So we have x plus change in x square. So this is the right way to do that. So in this case, we are going to have y plus change in y to be equal to, so we can expand this bracket. So when you have square, it is still the same thing as writing x plus change in x. Also, we have x plus another change in x. So this is what the bracket is telling us about. So you can square the bracket by having two brackets of the same variable or function. So in this case, we can expand this. So let's do that here. So when we have x plus change in x and also another x plus change in x. So in order to expand this, you take one bracket, which is this x plus change in x. So you bring what is in the bracket out. So we have x open bracket. You now write everything in the second bracket, which is what? X plus change in x. And also in this bracket that we are working with, we can bring plus change in x out, and we can write this second bracket again, which is x plus change in x. So this way you can easily expand it without making any mistake. So you use one bracket to multiply everything in the second bracket. So you bring x out, you write the second bracket, you bring the second power out, which is change in x, and you write the second bracket again. So in this case, when you want to expand, you can say x multiplied by x will give us what? X square plus x multiplied by dx will give us what? X dx. And also we have plus dx. So dx multiplied by x will give us what? Plus x dx. And also lastly, we have dx multiplied by dx, which will give us what? The x square. So when you solve this further, we have x square plus, so these two are like times. So we have x dx plus x dx, which will give us what? 2x dx, because they are like times. So we have plus the x square. So this is what we will get when we expand this bracket. So we can now bring that to our solving. So in doing that, we have y plus change in y to be equal to what? So when we expand this bracket, we get what? X square plus 2x dx plus what? The x square. So now that we have completed the expansion of the bracket, so the next thing to do, or the second step, is to take y to the opposite side, and remember that we have plus y here. So if it gets to the opposite side, it is going to change to minus. So we have the y equal to what? X square plus what? 2x dx plus what? The x square minus y. So remember I told you that the goal is to have what? Is to have the y only on the left hand side. So this is what you'll be following when doing your first principle method. Just make sure the y is on the what? Is on the left hand side. So anything here, you carry it to the opposite side. But we know that y equals to what? From the question, y equals to x square. So in solving this, we can now say that the y is equal to what? X square plus what? 2x dx plus the x square minus, so instead of writing y, we know that y equals to x square from the question, and that is how we have y equals to x square. So we can just substitute x square for y. So instead of writing y, we can just put minus x square. So we have x square here. So now that we know this, you can see plus x square and minus x square. So this can cancel this. So we have our change in y to be equal to what? 2x dx plus the x square. So when we have this, the next step is to do what? Is to divide everything by the x. So when we divide everything by the x, we have this dy over dx, which is change in x, to be equal to this also divided by change in x, and also this divided by what? Change in x. So when you solve this, this can cancel this, and also this is square, so this can cancel this. So we have our change in y over change in x to be equal to what? 2x plus dx, which is change in x. So if you are still solving and you have change in x in your final answer, the last thing to do is to what? Is to limit change in x to 0. So you limit change in x to 0. So you wholly apply this limit when you solve and you are still having the x in your question. So when we solve this and we limit the x to 0, we can have our change in y over change in x to be equal to what? So we have 2x plus, so when we limit the x to 0, that means anywhere we see the x, we put what? 0. So we have plus 0. So this is what the limit is working for. So we have 2x plus 0. And our final answer, which is the y, or change in y over change in x, will be given as what? 2x. And this is our final answer to question of this type. You can see when we use the general method, we get 2x. And also when we use the first principle method, we get 2x. So this is how you solve question of this type using the first principle method. You can see the idea is very simple. You just have to follow the steps. The first step is to what? Is to add change in y to y and also add change in x to x. And after that, if you are having a bracket with square, you will expand the bracket. And once you expand, the second step is to carry y to the opposite side and it will give you negative. So the goal is to have what? Just change in y on the left hand side. And when you do that, you are going to substitute y for what you have in the question. And you are going to cancel out everything here. And lastly, you divide everything by what? Dx. So when you divide everything by dx and you are still having the x in your final answer, the last step to do is to what? Is to limit the x to 0. And when you limit the x to 0, you are going to have 2x plus 0 and you have your final answer. And this is how we solve questions using the first principle method. So let's look at the last example on the first principle method. And moving to the last example on the first principle method of differentiation, we have the question as written on the board as y equals to 3x squared plus 2x. So in this kind of question, when we use the general method, so let's say we have something like y equals to what? We have 3x squared plus 2x. So if we use the general method, we are going to have y equals to, so the power will come to the front, multiply by everything, which is 3x, and the power will be subtracted by 1, plus also the power, which is 1 in this case, will come to the front. So we have 2x raised to power 1 minus 1. So our y will be given as what? So 2 multiplied by 3x will give us what? 6x raised to power 1. And we have 1 multiplied by 2x will give us what? 2x raised to power 0. So our final answer, which is the y over the x, will be given as what? 6x plus 2. Because anything raised to power 1 is that thing, and anything raised to power 0 is 1. So 2 multiplied by 1 will give us 2. So when we use the general method, we get 6x plus 2. So let's use the first principle method and see what this will give us. So remember, when we are using the first principle method, the first step is to add what? Change in y to y and add change in x to x. So in doing that, we have y plus what? Change in y to be equal to 3 open bracket x plus change in x square, because we are having square here, and we have lastly we have 2 open brackets what? X plus change in x. So this is the first step. You add change in y to y and also change in x to x. So you put the square outside the bracket and the variable, which is 3 in this case. So we put the 3 outside the bracket too. So also we do the same thing for these 2x. So in this case, we are going to expand these brackets. Remember, in our last example, I expand something like this. And when I expand, we are going to have y plus change in y to be equal to 3 open brackets. So when you expand it, you have x squared plus 2x dx, which is change in x. And lastly, you have plus change in x squared. So this is what you will get when you expand. You can check the previous example to see how I expand this bracket. And also, we are going to have plus 2 open brackets, what? X plus change in x. So in this case, we are going to have y plus change in y to be equal to what? So we are going to expand this bracket also by multiplying 3 with everything in this bracket. So 3 multiplied by x squared will give us what? 3x squared. And also 3 multiplied by 2x dx will give us what? Plus 6x change in x. And also 3 multiplied by change in x squared will give us what? 3 change in x squared. And also we are going to have plus, so we expand this bracket too. So 2 multiplied by x will give us what? 2x plus what? 2 multiplied by change in x will give us what? 2 change in x. So now that we have done this, the next step to do is to carry what? y to the opposite side of the equal sign, because the goal is to have what? Change in y on the left hand side alone. So we have change in y to be equal to, so when we carry y to the opposite side, we have 3x squared plus 6x change in x plus 3 change in x squared plus 2x plus 2 change in x, and we have minus, because this is positive, so when we carry y to the opposite side, we are going to have what? Minus y. So now that we have done this, we know that but y is equal to what? From the question, y is equal to 3x squared plus 2x. So we know that y is equal to what? 3x squared plus 2x. So we can substitute y for 3x squared plus 2x anywhere we see y. And in doing that, we have our dy to be equal to 3x squared plus 6x dx, which is change in x, plus 3 change in x squared plus 2x plus 2 change in x. So this will now be minus, what is y? Y is what? 3x squared plus 2x. So you can put that in the brackets because you are having more than two polynomials. So you have minus 3x squared plus what? Plus 2x. So this is y. So y is 3x squared plus what? Plus 2x. And that is why we put it in the bracket, because this minus will multiply everything. So you have to put it in the bracket, so you won't make the sign mistake in this case. So we are going to have the y to be equal to 3x squared plus 6x change in x plus 3 change in x squared plus 2x plus 2 change in x. So this minus will multiply this 3x squared. We have minus 3x squared. And also this minus will multiply this 2x. So we have minus 2x. So from what we see here, we can see minus 3x squared and what? 3x. So this is plus. So this can cancel this. And we can also see plus 2x and this minus 2x. So this plus 2x can cancel this minus 2x, yes. So we now have our change in y to be equal to what? 6x change in x plus what? 3 change in x squared. And also we now have lastly plus 2 change in x. So now that we have done this, the next step is to divide everything by what? By change in x. So we divide by change in x, divide by change in x, and also divide by change in x, and also divide this by what? Change in x. So when we divide this by change in x, this will cancel this will cancel this, and also this will cancel this. So we now have our change in y divided by change in x to be given as what? So we have 6x plus what? 3 change in x, because this square will cancel this change in x, and we now have plus 2. So you can now see that when we solve, we are still having what? Change in x in our final answer. So the last step to do is to what? Is to limit change in x to 0. So we limit change in x to 0. So in this case, that means anywhere we see change in x, we are going to put 0. So this is how you solve first principle method. If you are still having change in x in your final answer, you will limit the change in x to 0. So we now have our change in y divided by change in x to be equal to what? So we have 6x plus, so we now have 3 change in x, but we are going to limit it to 0. So we have 3 open brackets 0, and lastly we have plus 2. So you can see the plus 2. So we limit change in x to 0. So that means anywhere you see change in x, you are going to change it to 0. So we have our final answer, which is change in y over change in x, to be given as 6x plus 2. Because when you multiply this by 0, you are going to get 0. So 6x plus 2 is correct. And you can see when we solve using the general method, we get 6x plus 2. And also when we solve using the first principle method, we get 6x plus 2. So this first principle method is useful when you are solving theory question, because they might ask you to solve using the first principle in your theory exam. So you have to master it. It is very, very important. And this will be all on the first principle method of differentiation. If you found this video helpful, don't forget to like this video, hit the subscribe button, turn on the notification bell so you won't miss any updates or any lesson from Tech and EduSpark Hub, and share this video to more friends and more learners. And in our next lesson, we'll be looking at the first principle method of differentiation that involves fraction or rational numbers. So until next time, keep learning, keep coding, and I will see you in the next one.